In this lecture, we want to process this information, so we'll create a transaction struct for that. We'll also be creating a signature, which is this section. I'm going to minimize my visual, and on the left side here, we have wallet.go open. We have our blockchain address method here, and below this, we'll start writing. I'm going to create some space here, and first we'll write type transaction and create our struct. And for our field name, we'll name it as sender private key. Then write ECDSA private key. We'll also be using sender public key to create our signature, followed by ECDSA public key. Then we'll have sender blockchain address string. We'll include recipient blockchain address string. And then for the next line would be value float32. We have our public key, private key, and it's hard to see here, but our recipient and sender's blockchain address are also stored. We'll refer to this information to create our signature. What we've done is created a struct containing all this information. This part isn't new. Just like before, we'll start off with writing func new transaction, followed by private key, ECDSA private key, followed by public key ECDSA public key. And also this section here, sender string recipient string. And our value is float32. We'll return the pointer for transaction. Then return and transaction. We'll put our private key and public key, then sender, recipient, and then value. We just created a new transaction function. Now we'll write func t transaction. We want to create a signature, so let's name this generate signature. Here, we want to return a struct called signature. So first let's write type and create a struct with signature. This section with R and S big integers. We went over it in one of our previous lectures, so this may look familiar. We'll write here R big integer and then S big integer. With this, we're keeping our R and S position in our signature struct. This R can be referred to as our public key's X coordinate, and this S can be computed by referring to information like the transaction's hash and the temporary public key for generating signature. This can probably be better understood by writing the code, so we'll write the code for this shortly. First, let's look at this hash for transaction. We want to figure out this hash, so we'll use Marshall, then Jason, then Marshall T. We want to compute the hash for the transaction, and next we'll write func t transaction. We'll say Marshall Jason, followed by byte, then error. And within this method, we'll return Jason Marshall, then struct. Within this, we'll write sender string, then Jason sender blockchain address. We want to refer to this in our network, so we'll use underscores. We'll copy this, and next line will be the recipient. We'll replace to recipient, and the next line will be value float32 JSON value. We'll be using just these three transaction information. We don't need private key or public key information. We'll use only these pieces of information to initially work with our JSON Marshall function. We'll write sender and store T sender blockchain address here, followed by our recipient with T recipient blockchain address. Then next line will be value T value. When we want to create a hash with this information, first we brought it here with our Marshall. We're going to create a hash for this, so like before, we'll write SHA-256, SUM-256, followed by byte n. That's how we can compute our hash. So we just figured out our hash for this transaction. Now all we have to do is refer to our private key to generate our signature. We'll write rs And this time no error handling, so just ECDSA, and when we sign, we'll include RAND reader followed by T sender private key. Then just include our hash. We figured out our RNS, so all we need to do is return signature and include RNS. We want to see our signature later, so down below, let's write func s signature string, then override to string. Then our next line will be return fmt sprintf, %x followed by sr and ss. Now that we've gotten this far, let's go to main.go and call our method that we just created. We'll say transaction, then wallet, new transaction. Right now, in this section, we're creating a wallet. Let's say that this is person A's wallet and person A wants to do a transaction where person A sends cryptocurrency to person B. To do this, we need to include person A's private key and public key, followed by person A's blockchain address. This is the sender's information, and the recipient is person B. The value of cryptocurrency is 1.0. This is the struct for the transaction. Now we'll write fmt printf signature %s, then t generate signature. With this, we'll be able to return the struct for signature. We wrote a method for string in our struct, and that's why we can make it display with %s. Now let's try running our code, and when we do, we see signature, then our signature that we generated. Let me pull up my visual here to the right of our screen and make it bigger. We had our transaction and private key data, and we generated our signature. Now all there's left to do is send our public key, signature, and our transaction to our blockchain node side. And once we get to this side, we'll verify and everything will be completed. In our next lecture, we'll work on this section of verification.